So let us solve problems which are connected with power and energy, electric power and energy. An energy source forces a constant current of 2 ampere for 10 seconds to flow through a light bulb. If 2.3 kg is given off in the form of heat and light energy, so calculate the voltage drop across the bulb. So we are asked to calculate the voltage, and we are given 2 ampere of current, 2 ampere of current which is flowing for 10 seconds, a current in time, and 2.3 kg is given off in the form of light and energy. So we are given the energy, the amount of dissipated energy. So to calculate the current, we know that the current from the previous equation is that VAB is given dW over dQ. dW over dQ. So the power is V times solve this problem. As we said, V is given by delta W over delta Q. So we haven't been given the charge. We don't know the charge. To calculate the charge is given by I dt. Simply, we are given the current. The current is 2 ampere, which is flowing for 10 seconds. Simply, the Q is, both are constant for constant time. So 2 ampere times 10 seconds, which is 20 coulomb. So now we have the charge. So in order to calculate the voltage, we have the delta work. The delta work done is simply the amount of energy dissipated. The work done is equal to the amount of energy dissipated. So calculating this would give us 115 voltage. Now let's go to the next problem. Let us solve the next problem. Find the power delivered to an element at t is equal to 3 millisecond, at t is equal to some instant time, which is 3 millisecond. If the current entering its positive terminal is, the current entering the positive terminal is given by I is equal to 5 cos 60 pi t. The current is in a function of a time. We are given, so in the voltage is given by V is equal to A at V is equal to 3I, B at V is equal to 3 di over dt, the derivative of the current, 3 di over dt. Simply, so in this question we are asked to calculate the power delivered. So from the previous equation, we know that from the previous equation we have derived the formula to calculate the power. The power is simply dW over dt, which is dW over dq, V times dq over dt, which is equal to V times I. So remember this question. Now to calculate the power, to calculate the power, P is equal to V times I. So for question A, at V is equal to 3I, which is power is equal to V times I. The I is given by V is equal to 3 times I, 3 times 5 cos 60 pi t. Okay, so P is equal to VI. So we have given V is equal to 3 times I. First, let's find V. Let's calculate the amount of V. So V is equal to, simply given, 3 times I. I is, from the given, we know that the current is 5 cos 60 pi t. So this is not right here. Yeah, which is equal to 15 cos pi t. V is given by 15 cos pi t. Now let's calculate P. P is equal to simply V times I. So inserting this, I is given by 5 cos 60 pi t, and V is, as we calculated, 15 cos pi t. So calculating and rearranging this will give us 75 cos square 60 pi t. So this is power. So we are asked to find the power at t is equal to 3 milliseconds. So at t is equal to 3 milliseconds, inserting right here 3 milliseconds, 3 times 10 raised to minus 3. So rearranging and calculating this would give us 53.48 watts. Now let's calculate for B when V is equal to 3 di over dt. When 3 di over dt. P is equal to VI, V is equal to, we have given that V is equal to 3d 5 cos 60 pi. So we have been given that the current is 5 cos 60 pi t. So we need to derivate this function of current in order to find the amount of the voltage, which is equal to 3 times the derivative of 5 cos 60 pi over dt. So the derivation of cos 60 pi t will give us minus sine, bringing 60 pi right here. So 900 pi sine 60 pi v. So P is equal to V times I. So inserting this V, as we calculated, 900 pi sine 60 pi t, and the current is 5 cos 60 pi. So calculating this would give us minus 4500 pi cos 60 pi t sine 60 pi t. So inserting at t is equal to, we are asked at t is equal to 3 milliseconds. It's just simply inserting 3 milliseconds in place of t. So we will find minus 6.396 watts. This is the amount of energy dissipated. When it is negative, power is said to be dissipated, or when it is positive, power is absorbed. As you remember, when it is positive from A, when it's positive, power is absorbed. Thank you.